Enumerations, enumeration, or enum for short, are user-defined data types. We normally use these to assign constant names to integral values. And this way, it makes it very easy to read and maintain source code. Enumerations, enumeration, or enum for short, are user-defined data types. We normally use these to assign constant names to integral values. And this way, it makes it very easy to read and maintain source code. The keyword enum is used to declare a new enumeration in C. So here we have the keyword enum, and this is the name of the enumeration. Flag. And then we give it the constant values. As a result, the behavior in C is that the first constant is given the integer value of 0. Every constant after that increments by 1. So we can use variable of type enum to define them. And we can define them in two different ways. So here we see the definition of the enumeration week, and it has 3 valid values: Monday, Tuesday, and Wednesday. So now I am creating a variable of the data type enum week, and I'm calling it day. The other option to accomplish the same thing is we declare our enumeration called week with available values of Monday, Tuesday, Wednesday, and we're going to call a variable of this enumeration day. So let's look at the source code example. So here I have multiple enumerations defined. The first one is an enumeration called week. Valid values of the week are Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. I have another one called year, and valid values of the enumeration year are January, February, March, April, May, June, July, August, September, October, November, December. And we'll look at this example in just a moment. So it is possible to have an enumeration or multiple enumerations where we have names with the same value. So we don't explicitly assign values to enum names. Actually, the compiler by default assigns values starting at the value of 0. We can assign values to some name in any order that we choose. All assigned names get a value as a value of the previous name plus 1. So here is an example. So I have in my enum state working is a 1, failed is a 0, unfreezed is a 0. So this exemplifies the idea that two enums can have the same value. This example here, enum day 2, demonstrates the ability for me to assign a specific value to one of the enums. So as a result here, Sunday is 10. And because of the default behavior of enumerations, all assigned names get a value as the value of the previous name plus 1. So that means Monday is an 11. Well, Tuesday now is explicitly assigned the value of 15. So that means Wednesday is a 16. Thursday is explicitly assigned the value of 1. Therefore, Friday is a 2, and Saturday is a 3.
I can count.
So the value that's assigned to an enumeration name must be an integer value. So it has to be an in some range from a minimum possible integer value to a maximum possible integer value. Enumeration constants must be unique within their scope. Scope meaning the open and close curly braces associated with the enumeration definition and the associated values or numbers. So this situation here is associated with the enumeration definition and the associated values or numbers. So this situation here, enum state, defined with working and failed, and then enum result with failed and pass, would not compile, because failed is used twice. And therefore, it does not have a single literal value associated with it, because in enum state, failed is a 1, any new result, failed is a 0. Therefore, they conflict. So one of the ways we can accomplish the same behavior with enumerations is potentially a macro or a pound define. So we could declare individual constants or macros using the pound define preprocessor command to associate an integer value with each one of these constant terms or variables. So we have pound define working as 0, pound define failed as 1, pound define freezed as 2. Rather than writing 3 lines of code, we could simplify this process by declaring an enumeration. And so we give the enumeration a state, we give it the 3 terms we would like to associate with those states, working, failed, and freeze. And by default, because of the behavior of enumerations, the first value automatically is assigned a 0, the second value is a 1, the third value is a 2, and it increments by 1 per enumeration member. So here, we would have working automatically as a 0, failed would automatically be a 1, and freeze would automatically be a 2. So enumerated types, even though we are using a string to define them, they're actually keywords or constants. Yes, they do have an integer value associated with them, but it's important to understand that they really are not strings. So once they're defined, the compiler can process these enumerations. So black ops would be 0, top secret would be 1, secret is a 2, and non-secret is a 3. It's very important that at the end of your enumeration declaration, you don't forget your semicolon. So once we have our enumerations defined, to exemplify the fact that they are not strings, it would be inappropriate to use a string compare function from the string.h header file to do a comparison. So here I have a variable of that string.h. At the end of your enumeration declaration, you don't forget your semicolon. So once we have our enumerations defined, to exemplify the fact that they are not strings, it would be inappropriate to use a string compare function from the string.h header file to do a comparison. So here I have a variable of that enumeration called my security level, and I was checking for equality to one of the values, black ops, top secret, secret, non-secret. I would just compare it to that enumeration variable name. I would not do a string compare because they are not strings. So there's two different ways to do a string compare, and neither one of these function implementations is appropriate for enumerations. So though enumerations are not really integers, when we work with them programmatically, we do consider the integer value of them. So yes, they are treated like integers by the compiler. Yes, they will automatically be assigned an integer value of 0, 1, 2, 3, etc. But they're really enumerations, which is a data type in and of itself. So though we shouldn't rely on the fact that they have an associated integer value, we do use that, and programmers do incorporate this into their programming applications because it is very handy for comparison versions. So we looked at the idea that we had black ops, top secret, secret, non-secret. So when we looked at the definition of this enumeration, in reality, but they're really enumerations, which is a data type in and of itself. So though we shouldn't rely on the fact that they have an associated integer value, we do use that, and programmers do incorporate this into their programming applications because it is very handy for comparison versions. So we looked at the idea that we had black ops, top secret, secret, non-secret. So when we looked at the definition of this enumeration. In reality, from a programming perspective, we can expect an integer value to be associated with them as 0, 1, 2, 3, and increment from 1 by 1 from there. So let's look at the code example. So my first example here is I'm creating a variable of data type enum week. The two words together define the data type. So let's focus on this here. And this will come in handy when we start using structs and we have to create variables of a struct. And structs very much follow the same paradigm, where it takes two words to define the data type. So enum week is the data type. We know that because here, up above, we defined enumeration called week, and we gave it the two words expect an integer value to be associated with them as 0, 1, 2, 3, and increment from 1 by 1 from there. So let's look at the code example. So my first example here is I'm creating a variable of data type enum week. The two words together define the data type. So let's focus on this here. And this will come in handy when we start using structs and we have to create variables of a struct. And structs very much follow the same paradigm, where it takes two words to define the data type. So enum week is the data type. We know that because here, up above, we defined enumeration called week, and we gave it these 7 valid values. So if I set my variable day equal to a valid enumeration constant of Wednesday, then I can output that value. And I can output it as an integer, and I'll get the results back. So here a Wednesday shows up as a 2. The reason why Wednesday showed up as a 2 is because Monday is a 0, Tuesday is a 1, Wednesday is a 2. The second example I have here is I'm going to loop through my enumeration that includes January to December. So notice that I can initialize my looping variable I to January, and my condition to continue to loop is based on the enumeration December. So January starts as a 0, December is going to be my 11. And I'm going to loop through each one of these and output the integer value of that enumeration. The third example here is going to exemplify I have 3 values for my enumeration state. Working is a 1, failed is a 0, unfreezed is a 0. So this proves that it is perfectly okay with enumerations that if one of the enumerations has an associated value, another enumeration can have the same associated value, and there's no issue with it. The fourth example here is exemplifying using this in an enumeration day. Enumeration day Starts at Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. So I am declaring a variable of enumeration day. Locally, I'm calling it D, and I'm setting it equal to Thursday, and I'll output that value. And then the last example here demonstrates just outputting the values of an enumeration that has a definition of Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. So this example here is showing this enumeration where I have an initial value where Sunday is 10. And again, Monday is going to be 11 because it just increases by 1. Tuesday is now 15. So Wednesday is going to be a plus 1 from Tuesday. So that's now a 16. Thursday clearly is a 1. So Friday is going to be 1 plus what Thursday was. And Saturday will be 1 plus what Friday was. So you can see here Saturday is a 3. And Friday is a 2. And so we will see that output here. Okay, so I have the output here from the code example. The first example here demonstrates that I created a variable of a noon week, and I called it day. I set day equal to Wednesday. The output of day results in a 2. So we have Monday is a 0, Tuesday is a 1, Wednesday is a 2. So there's our 2. Then the next example, looping through January to December. So January is a 0, and December is going to be 11. So you can see the 1 through 11. Here I have an enumeration where one value is unique and two values are the same. So I output those values here. So I have the 1, the 0, 0. Example 4 creates a variable of a noon day, locally called D, and I set it equal to Thursday. So go look at our noon day, and there's our Thursday. So that's a 0, 1, 2, 3, 4.